Hey guys, welcome back. This is the second video for section 1.1. I'm just going to pick up where I left off. A system of linear equations in n variables is a set of m equations, each of which is linear in the same n variables. So these are the m equations. That's how many there are, okay? There could be 5 of them, there could be 3 of them, and so on. So there's m equations, and there's n variables, x1, x2, all the way to xn, okay? So once again, when you're reading this, you really have to hear the vocabulary and understand the notation. Just want you guys to know that this here typically represents row and column. So this is first row, first column. This is second row, first column. This is second row, second column. This is first row, second column. So some of you may have seen it in pre-calculus. Okay, so a system of linear equations in n variables is a set of m equations, that's all this, each of which is linear in the same n variables. A system of linear equations, we're going to go right down here, is also called a linear system. A solution of a linear system is a sequence of numbers, what we call S1, S2, S3, all the way to Sn. That is a solution of each equation in the system. So what basically that means is that when you get the answer for x1, x2, and xn, it must satisfy every single equation. So let's take a look at this. If we had 2 equations, in this case m would be 2, we had 3x1 plus 2x2 is equal to 3, and negative x1 plus x2 equals 4. We know that x1 equals negative 1 and x2 equals 3 if you solve for it. So what we're going to do here is we're going to make sure that you get negative 3 plus 6 equals 3, but that's a solution just for this. You have to check to make sure it satisfies this one, and then basically it will. So that's 1 plus 3 equals 4, and so it satisfies all of the equations. So that's what this says here. That's what this means. A system of linear equations is also called a linear system. A solution of a linear system is a sequence of numbers that is a solution of each equation, okay? A system of 2 equations has either no solution, 1 solution, or infinitely many solutions. Well, basically in algebra, you learned if 2 lines are parallel, right, linear, right? If 2 lines are parallel, they're never going to touch. This has the same number in front of the x and the same number in front of the y, but their starting point is different. So these will have no solution, okay? This here is actually exactly the same. If you multiply this by 2, you would get exactly this. Therefore, this has infinitely many solutions. And if it's no solutions, if it's not no solutions because they're parallel, or if they're, and it's not exactly the same and giving you infinitely many, then it must intersect and only 1 solution. So this will have 1 solution, okay? So no solutions if they are parallel, which means that they match everywhere except for the constants. Infinitely many if they are exactly the same except for one of them is just the multiple of the other one. And then just once if neither one of those 2 are satisfied. Question: which system is easier to solve algebraically, the left side or the right side? Well, I definitely would say the right side. If you guys wanted to solve the right side, we would do something called back substitution. What we would do is we would take 2, plug it back into here, you would get y to be -1, take that and the z of 2 and plug it back into here. This is called back substitution. So when you do that, what you would end up getting is x to be 1, y to be -1, and z to be 2. This is actually very simple. All we did was back substitution. And one other reason why this is simple is because the right side is in such a form that it makes it so simple to solve. That form is called row-echelon form. And basically, row-echelon form means that there's a 1 in front of what we call a staircase, right? So like a stair step kind of thing. So what I mean by that is that there's a 1 there, there's a 1 there, and there's a 1 there. So if you get the leading coefficient to be 1 in this stair step pattern, you are in row echelon. Okay, so row echelon is going to be really important in linear algebra. So you want a 1 there, a 1 there, and a 1 there. Okay, so let's go on. Two systems of equation are equivalent when they have the same solution set. What does that really mean? Two systems of linear equations are equivalent when they have the same solution set. Isn't it true that for this and this, and for this and this, they're going to yield the same solution? Take a look at it. Of course they are. They both will yield x equals 1, y equals 1. Right? So you might say, well, a lot of things will give me 1, 1, but two systems are identical when they give you the same solution set. To solve a system that is not in row echelon form, first rewrite it as an equivalent system that is in row echelon form. Now there are three operations that you can use to create this equivalent systems. Okay, so rewrite it into something equivalent. Take a look at what I did here, guys. All I have to do is multiply this by 2. Remember, if you do something to the left side of an equation and you do it to the right side of an equation, it balances out and it's basically legal. If you guys think about it, 2 plus 3 makes 5, right? If you multiplied this whole thing by 5, you would go 10 plus 15 makes 25. Isn't that also true? So the first thing that we can do to create these equivalent systems is you can interchange two equations. Okay? What does that mean? That basically means that if the first equation is 2x plus 3y equals 5, and the second equation is 4x plus 5y equals 9, you could just switch these two around. Of course you could. You might say, well, why do we want to do that? Well, once again, you want that 1 up in the left corner, and there might be a 1 in one of the equations, so you might just want to start by, putting this person up here first. So you can interchange two equations. You can multiply an equation by a constant, which I just showed you. You're not changing anything when you do that. And then you can add a multiple of an equation to another equation, okay? So these are your three things that you can do, the three operations, and you will still produce equivalent systems. So I'm gonna do one example with you and then we'll stop the video. This example is the example that I had here. X minus 2y plus 3z, negative x plus 3y, 2x minus 5y plus 5z equals 17. So that's what we have here, okay? So I have these here, and I want to try to get it into row echelon form. So here's what I'm going to do first. I'm going to start by adding the first equation to the second equation. Why did I do that? Because I noticed that this will give me 0, right? But when you add the first equation to the second equation, you want to figure out, do you want it to equal the first equation or do you want it to equal the second equation? My first equation already has a 1, so why would I want to mess with that? I don't. So this gives me 0, therefore there's nothing here. This gives me positive 1y. That's great because now I have that staircase of 1. And then this gives me the 3z, okay? 9 and negative 4 gives you 5. You got to do it to everyone. Okay, so that's what we're going to do there. So we added the first equation to the second equation to produce a new second equation. Now what I'm going to do is I'm going to take a look at this here and figure out what I should do next. Well, what I'm going to do now is I'm going to multiply, okay? So first, I'm going to add negative 2 times the first equation. So I'm going to multiply the first equation by negative 2. And then I'm going to add that to the third equation to produce a new third equation. So what does that mean? You're going to basically multiply. Remember, since you are changing the third equation, don't touch the first, even though that you're multiplying it. So you're going to multiply this by negative 2. This becomes a positive 4. This becomes a negative 6. And this becomes a negative 18. Okay? But we're not touching that. You're going to multiply this whole thing by negative 2. And you're going to take this and add it to this. And that's going to make this part disappear also. You're going to do this with this. And that's going to give you the negative y. And then you're going to do this with this, and that's going to give you the negative z, and this gives you a negative 1. Now take a look at what you guys see. You see this and this, if you want to combine it, will disappear. But remember, you want the 0 in the third because you want it to be 1, 1, and then 1 here. So let's combine, okay? Add the second equation to the third equation to produce a new third equation. So here we are. When we go to combine this, this gives me 0 right there. This gives me 2z. This gives me 4. Remember, you can multiply an equation by a non-zero constant. You can multiply. So all I'm going to do, I know that you guys are just saying, why don't we just divide? Because we don't like to use the word divide. Don't ask me why. If you multiply by 1/2, you get z to be 2. And look, everyone, you literally get back that first equation that we did the back substitution for. Did you guys know that this and this are identical? But we got this to be this. So what you want to do is you want to get that staircase of 1, what we call row echelon form. And that's going to help you solve equations, okay? So I hope this video was helpful. Come back for the next video.